This is the answer to Chapter 3, problem number 41 from the Smith Organic Chemistry textbook. And in this problem, we're given four fairly complex molecules, and we're asked to predict the water solubility of each. And so in order to do that, remember this rule that the book suggests that I've written up the top of the screen here, which is for every 5 carbons in a molecule, it needs to have one polar functional group capable of hydrogen bonding in order to be water soluble. So looking at A, we can see right off the bat that 1, 2, 3, 4, 5, 6, 7. There are 7 carbons in this molecule, and 1, 2, 3, 4, 5, 6 polar functional groups. So this molecule is very polar, and it is water soluble. So that's caffeine, by the way. So looking at this steroid molecule that we have for B, so we can see that there's an ether here, the OCH3. So this is an ether. This is obviously an alcohol. And that's it. 2 polar functional groups that could H bond, and many more than 10 carbons. We have 3 6-membered rings and a 5-membered ring, and then some branches and stuff. So well over 10 carbons. And so the answer to B is going to be not water soluble. Because remember, in order to be water soluble, it needs to have one polar functional group per 5 carbons. And that's not the case in B. C, we don't even need to count. Look at all of those OHs. There are also some ether O's in there. And so this is obviously water soluble. And by the way, this is sucrose. So this is table sugar, which we know is water soluble. Okay, so then looking at D, we have a single polar functional group, many more than 5 carbons, and we can say just by looking at this that this is not water soluble. Remember, there has to be one polar functional group capable of H bonding per 5 carbons. We have, 15 or 20 carbons here, and only one alcohol. And so that's not going to work. That molecule is not water soluble. And let's see, what is that? Carotoxin. So this is some type of poison. So it's probably good that it's not water soluble. And so that's the way to approach this problem. Just remember this one polar functional group per 5 carbon rule, and then apply it to these structures. And that's the answer to Chapter 3, problem number 41.